All right. Hello, everyone. We're gonna get started. Okay, so go to bright space. Okay. Can you just sign in and pass this around? All right. So make sure to sign in on the sign-in sheet. Okay, so let's get started. So today we have several things that I'll be doing. One of them is kind of going over the GPU Scholar, right? So we'll go over that. Then after that, the homework assignment, as you know, I've already started loading that, and I'll explain that further. So we'll go over that as well. Okay, this is your next main assignment. Okay, so guys, guys over there. All right. And then after that, we do have some topics. We finished a complicated algorithm. One could argue one of the most complicated algorithms out there in machine learning. And we went over it thoroughly. So hopefully that gave you a lot of insight into programming tricks for deep learning and neural networks. Today, we're going to go back to some of the more fundamental concepts. So we're going to talk about curve similarities, normalization, softmax, gradients, and a little bit of optimization. All of this will be in PyTorch, of course, so it's not really going to be like, the math equations, but I mean, they are there. They're just going to be in PyTorch, okay? So it's several scripts. There's really not like one whole thing. Instead, once again, I've broken this out into individual problems. So before, if you remember, you did the 109 tensor operation problems, right? And that was just, creating tensors, playing with them, but you really had random data in them, of course. Now in this one, the idea is, the optimization parts and all that. So we'll do several examples of that. All right, so I'm going to start with the homework assignment. So I believe I've loaded this for section 1, I want to say. Let's take a look. So it says that section 1 was the latest thing I updated. So let's take a look. Yeah, so it's here. All right, so basically, I'll update this for section 2 as well. But we have covered all of this: performance metrics, loss functions, DL homework, right? So that's due probably tonight. It's due this week, right? So this is coming up. So this homework assignment, so make sure you ask questions if you have any on this assignment. I believe this was 3 cybersecurity data sets, mostly classification problems, and you have to implement them in PyTorch and submit your work, right? Okay, so that's the homework that's currently to be submitted. I added the new topic that we covered the last 2 weeks or so. This was GPTs, and I have the homework assignment here. So basically, I added a link for the notes, which I used throughout the discussion of the lecture, right? So those were the notes. Okay, and then I added the link for the code. So the code that we did in class that there's 4 parts, right? So 4 videos, and this is the code, and it was this GPT and Huck Finn, basically, right? So we went over this, and the idea was to train, for that example, a Huckleberry Finn. All right. So go back to that folder now. Table of contents here. All right, and I added the assignment basically, right? So I had talked about this a little bit. I'll talk about it a little bit more today of what I want you to do. Okay, so let's go over the dates for now. Oh, yeah, sorry.
Have you added this section for both the
Yeah, I think that I didn't do it for one of the sections,
Yeah.
right? It's missing. Okay, I will add it. I apologize. I keep doing that. But yes, I will replicate this for you guys. Sorry about that. So the assignment I wanted to discuss, first of all, so pre-trained GPT. So hopefully that says everything. Let's talk about the dates first, just to make sure we're all on the same page. So I think I'm gonna update dates. Give me a second. Hmm. Oh, okay, here it is. All right, so start date, add a start date. So, it can start now. So today's the 21st, so it'll start on the 15th. That's fine. Due date. So I was thinking about this. So today's the 21st. So I'm going to make it so it's due November 4th, okay? That gives you about 2 weeks. I'm still going to give you a little buffer after. But this is your assignment. Actually, the hard part is probably not training the GPT, but it's collecting the data. That's one of the points in this class, right? To deal with social media data, suffer a little bit with that, right? So that's kind of what I'm looking for. I created a new assignment this semester, and I want you to build a vet GPT. And what I mean by that is a veterinarian or veterinary medicine, right? So that's what I'm looking for. And the best one gets a trophy, right? So but that's kind of the idea. Okay. So now how are you going to do this? You have to only pre-train it, right? So that we're not using any libraries like Hugging Face or any, for those of you that are familiar with Hugging Face, that's not the goal of this class. I'm not doing transfer learning. In this one, I just want you to focus on the pre-training aspect. You will use the code that we discussed during the last 2 weeks. That 4-part video discusses everything. That code runs perfectly fine. There's no issues. That challenge is really collecting the data. Okay, so I'm doing so the date due November 4th. I'll give you an extra week for end date, but try to submit it by then. So it'll close on that Sunday. All right, and I'm going to update it. Okay, so the dates are there and you guys can see them. All right, so now let's go to the discussion of what you need to do. So train a GPT from scratch to be a vet GPT, right? So veterinarian. Okay, you need to scrape the data from the web. And I provided some links here. That doesn't mean that you just have to use these 2 links, okay? If you want to win the trophy, let's say, you're gonna need a lot of data, right? So that's what I want you to think about, right? So that's the whole point. So obviously, I had a statistic the other day on one GPU, on one normal GPU, like the one that most of you have at home. So those of you that have GPU boxes, so those 2080s or whatever they are, it would take, I think, 655 years to train GPT-3. Okay, on one GPU. So obviously, OpenAI and them had clusters of GPUs, and they were able to train this. Still, it took months, probably, and millions of dollars. But I did read that statistic recently: 655 years at least to train with one commodity GPU box, GPT-3. Okay, so keep that in mind. So it takes a lot of work. But still, this is a course, so you can explore interesting things, okay? So I will say no fine tuning because that would be cheating, right? In this like challenge, if somebody downloads the weights of Llama 3 and just fine tunes it, it'll probably be a better vet GPT, right? So the goal is kind of just to see how you guys can think about the problem, maybe invent a new system that doesn't require 10,000 GPUs, right? And so, but yeah, that's the challenge. So use Also rules, I guess. Rules, I'll say. Use, maybe this will work. Use one GPU or more, I guess. You can. One or more GPUs. I will provide Scholar, and as I said, I'll provide instructions on that one today. It should be pretty straightforward, but it's kind of on you. Okay, that's Scholar is kind of a thing that you have to figure out on your own, but it's easy. Okay, so it shouldn't, and I'll show a quick demo of how it works. Use one more GPU. What else? No fine tune, no libraries. Such as Hugging Face, etc. No fine tuning. Okay, so only pre-train only. So you must so pre-train, I will say pre-train. And so what does that mean, pre-train? So there is pre-train and fine-tuning, right? These are concepts that if you take 530, you'll learn more about. But basically, pre-train means you have the code from scratch. The weights are all random. You start giving it data. 655 years later on a commodity GPU, you got good weights, right? So that's basically what pre-train means. And then after that, that's a very generic, you can think of it as a generic model, but then you would have to fine tune it to do specific things. So basically one pre-train idea would be give it all the text in English and then fine tune it with this data to become a VED GPT. It would probably be a very good VED GPT actually. So there's a lot of tricks that apply there. But for this one, just basically like the Huckleberry Finn example that we did in class. And if you can think of nice ideas within the pre-trained domain. Got it? So that's really what you can do research as long as you meet the condition of pre-trained. So I'll say no fine-tuning, pre-train only. Is this concept clear, guys? Or is there anyone that doesn't quite get that? Yes, sir.
So they're only supposed to feed a data. You're not supposed to give it a feedback. So
Feedback. Well, that's interesting. I would be okay with feedback and any kind of strategy. You just can't borrow someone else's weights. Like you can't take a classmate that did the homework and then they give you their weights and you're done. That's also cheating and that's fine tuning also. So, or you can't get the weights from Facebook or OpenAI or Llama or whatever. You have to start from random weights, train your data, and then arrive at the set of weights that you get. As I said, I don't expect your models to be great, but be creative. That's what I can tell you. That's the whole point, is explore that realm of pre-training here. What happens is a lot of people just say, okay, I'm not even going to bother with pre-train. I'm just going to go to fine-tuning. And you know what? I'm just going to hire someone to do this for me. And you know what I mean? And they don't do anything. But, there's room in the research space. Someone, I guarantee you, 15 years from now, will figure it out, right? To make it more efficient. So that's kind of where I want you guys to focus on. Pure pre-train, read papers, be clever. And at the end of the day, you're all building the same VED GPT. We'll need to find a way to measure who's got the best one, right? So maybe we'll find some metrics for that, or we'll find or qualitative analysis on a random basis, something like that. You will present this topic. This is kind of a mini project homework that we will do. And we'll probably do one more of these, okay? Any questions? All right, so hopefully this is clear enough. It's in the video, and like I said, I will update this at the end of class today. So pre-train a GPT from scratch to be a VED GPT. Rules: use one or more GPUs, no libraries such as Hugging Face, etc. No fine-tuning, pre-train only. Yes.
What about the architecture?
The GPT that I gave you.
We should not change any of that.
Well, it is a GPT. So what do you suggest that might be better?
No, I mean, just having more parameters.
Oh, you can. Yeah. If you want to add the architecture of like a Llama 3 or a GPT-3, you can. Yeah.
And then it simply becomes a race of who has the better GPUs and
No, exactly. I agree. Like whoever in today, I'm not saying that, it's true. The scaling law says more GPUs, more data, more architecture, better model, more money. But at the end of the day, then if that's the rule, then just like 5 companies in the world can do this, right? So hopefully that's not the case forever. So I assume people are clever, right? They invent smart things, they'll figure it out so that it's not just concentrated in the hands. It's kind of like you guys know the GPT right now. Eventually there will be an innovation that you can just plug in there. And hopefully you'll be able to train your own models clearly instead of, just getting to the point where you're paying for everything, right? So, all right, so that's the idea. So hopefully this is clear enough. When I say at GPT, I'm kind of suggesting that you use the code that I described during those 4 videos. All right, you need to scrape the data from the web. And this is important. You can use any crawlers, right? Crawlers or web scraping tools. So I leave this to you guys. I'm not at all asking you to write this code from scratch. There's plenty of very robust libraries out there that allow you to just download like HTML documents and scrape the data, and you'll have to think about how you do it. Okay? So there's but the idea, I mean, in its simplest form, you create something that looks like a book, right? Just extract the text. Don't extract the metadata like the tags and all that stuff. It may not be useful, or maybe it could be useful. I don't know, honestly. So you can think about that one, right? But in essence, though, that's the goal, to play with these ideas, do some Google searching, read some papers, watch some YouTube videos, try to create the best data set. And then at the end we're going to give it questions and answers. That's kind of the idea. So, how do I treat my pet for this? And then, things like that. Got it? Well, we may even have a vet review your answers. No, I'm kidding. All right. As far as the link, so as I said, use a crawler or a web scraping tool. You can use any crawler or web scraping tool, and then you will collect the text. I've provided these links here, so I'm just gonna update this, and then I'll click them. These are Vin is like a very well-known source of veterinary data. Right. So this is a very well-known source. What didn't open? Yeah. So it's veterinary partner, and it's provided by Vin. And I understand this is like open. So you can start here if you'd like, just to know where to go. And I provided another link, I think more like research papers and all that. And so, yeah, so that's your challenge. So let's take 2 weeks for now, because remember, we're on week 10 of the semester, I think, or week 9. So we don't have much time left in the semester, right? So we'll still cover CNNs and those topics and a few other topics, obviously, but this is one of your main homework assignments. And like I said, I'm still thinking of one or two more instead of a big project. Okay? I like to do mini projects instead of project. That's it. Question. Do we have a second exam? That's going to be on week 12, but an easy exam like the previous one. Closed notes, but you're allowed your cheat sheet, and then it'll be mostly about GPT. So you can expect a whole bunch of simple questions about GPTs, most likely, and then there will be the final exam. All right, so hopefully this makes sense. I think I've only updated this for one section, so what was this? Give me a second, guys. All right, so as I was saying, I think, yeah, section 1 is where I've done the update. Okay, so yeah. So this module basically is the one that you are going to focus on, and I'll update this for the second section, okay? Any questions before we move on? All right, so the next thing we're going to cover today is GPU Scholar. Obviously, you need a GPU to be able to train this. It will never train on your CPU. You saw that last week. All right, so how do we do that? So I added a document under resources. So you guys are seeing this here. And it should be this troubleshooting GPU Scholar. So I'm going to open that. This is usually the resource I use. So GPU Scholar, you need to basically let me know if you have any issues logging on. They told me, because they add your account into a course and everything. And then so you should be able to log in at this point. If you have problems logging in, email me, please. Tomorrow. Try it. It may just be that, because a lot of you may be logging in right now, there may be some issues. But if you haven't been able to log in by tomorrow, send me an email and I'll try to figure out what the problem is. Okay. So what is GPU Scholar? So this is something that has existed at the university for, I think, 10 years or so. It's actually at the end of its life, is my understanding. And they're thinking of what to do next. But it's it's like a cloud. You can have more than one GPU, but in general, I think the default is one GPU. The support is for one GPU, okay? It's a queuing system. So this is the whole Purdue system. So, there's people from, West Lafayette and Indianapolis and wherever. They're all trying to get in here, and you can only get in here, on a first come, first serve basis. So, if you all try to get in right now, you won't get a GPU. That's almost guaranteed. There's several types of GPUs. There's 830s, Teslas, I think H100s, and then they have these MIG ones, which is basically like one GPU divided out into, like, they serve a piece of the GPU. All right, so you'll see that there's several ones. So please don't log in yet. Let me try to get in so I can demo how this would work. And then your environment will look a little bit different than mine. And that's just because, I've tried this several times. So, all right. So basically read this whole document just so that you get some information. In general, I just use this link here, rcac purdue.edu. So I'm going to copy that one. You guys can see it. Okay. Right, so I'm able to get access here. I'm already logged in, so I assume it'll use your two-factor authentication, your token, right? So click on that. I'm sure there's a prompt or something. Log in, right? And then once you're there, all right, it's a big platform, so I'm just going to show you kind of what I do, but there's more options that you have. Okay, so one thing that I do is sometimes I click on cluster and I click on Scholar Shell Access. And this gives you a little bit, like a terminal, basically. So you can see this. I'm going to do clear here. -L. It's like Linux. right? So you can basically do things. One important thing to watch out for is this thing called my quota. So it's basically, like a restricted space. So for instance, I have 23 GB here out of 25. If I exceed that, things won't run. I won't be able to create Jupyter notebooks and things like that. So make sure you're clearing that. You do have this other space called Scratch Scholar. And if you go to Scratch Scholar, if you look, that has 1 terabyte. So you can basically put when you're training your vet GPT, maybe you want to put all your data in Scratch. It should be /scratch/scholar, and then put your data there, and then reference it from your script, and then you won't run into problems. Okay. So if I do PWD here, you can see I'm currently logged into this one, Hallmark Calix. If you do probably CD Scratch, CD Scholar, and then let's see where it puts me. I can't remember. Yeah, so you can see it's reading a lot. I think the next step is to do CD your user, and then oops. And that should get you into your space. So I'm almost certain it's Scratch, Scholar, and then your user. Got it? You'll have one terabyte there. The other one has a little bit less. All right, so you can terminate that one. But yeah, that's usually for my quota, and I'm sure those of you that are really great at Linux can figure out things in there. All right, then usually, you can just click on this. This takes you to this. So home, that's my area. See, I have all these home directories. And then basically, I just use this Jupyter Notebook thing. So there's also Jupyter Lab available. You can also click on like desktop and then select. So there's various options. You can see that here. If you select it like this, it's going to take you to the desktop, right? I usually, for whatever reason, just do Jupyter Notebook. And once I'm there, I'm going to select a GPU. All right. So in this case, the way it works is queue, right? So you need to select what you're going to use. So there's these GPU MIGs that I was telling you about. These are like shared, so they're probably not going to be as fast. Okay. Keep in mind, if you get one of these GPUs, it's like you're holding a whole GPU, but only for 4 hours. After that, or maybe 2 hours, I think, and then you'll get kicked out, right? So you got to watch your training time, right? So one solution for those of you that are doing a lot of training with your vet GPT is checkpoints. What a checkpoint means is you're training for a while, 2 hours, 5 minutes before the end of the 2 hours, save a checkpoint. It's very easy to do in PyTorch. Then when you're starting the next 2 hours, read the checkpoint, continue training, and so on. It's totally doable. We might do a little example of that, but it's very straightforward. Got it? Yeah, so welcome to the world of dealing with big AI stuff. You have to start thinking like this. You have to break your training into things. You're limited by what you're provided. At least you can do the homework with this. Without it, if you don't have a GPU at home, you won't be able to do it. All right, so basically GPU max. Keep in mind also other people may need this. So if you don't just open a GPU, use it for 5 minutes and leave it open, right? If these are instructions that were given to me to tell you guys, if you're done with your thing after 7 minutes, delete it, and then the GPU will become available to someone else that needs it. Maybe one of your classmates or somebody, somewhere else. The waiting time, wall time, sorry, is 2 hours. You can see that number of hours you're requesting for your job. So basically you have 2 hours to finish the job. I usually use the default. I guess the max is 4 hours. You can probably try that. And then you can let these parameters as default. So 16. For the homework, you only need 1 GPU. Multiple GPUs and all that is a little bit more challenging, right? So it requires a few more libraries. but one GPU should be fine. First available is so that you don't, like if you want a specific one, like a V100 or an A30, you can select it. But otherwise, it's just going to give you one. You can select to use Jupyter Lab instead. So I'm just going to use my Jupyter. So then you would click launch. All right. And you can see it's thinking there. The session is currently starting. And it's telling you that you have an hour and 59 minutes, basically. All right. So that's it. So in my case, I was able to get one. So now just, look at the clock and then you can click on connect to Jupyter. Generally speaking, once you have a GPU, they're not going to kick you out. So they'll, it's not like you have to worry that you've spent an hour and a half and then got kicked out, right? So, but after the 2 hours, they will be out. All right, so that's kind of it. As I said, you're basically now, and I'll show you guys like a little example of how to check things. Try to move this somewhere. All right, but this is, as you can see, it's like a file system, shows your desktop, downloads, things like that. You can create Jupyters here. You can install things, read the document I provided. Basically here, you'll click on new. This will look different for you guys because, over the years, I've added things for various classes, but in general, you should have fewer of these. Play with them, like try each one, like Python 3.7, 3.8, right? If that's available to you, or install your own. There, you can. It's not like you cannot, but it's not trivial. You got to figure it out. All right. The key thing is once you get one of these Jupyter notebooks, you want to make sure that you have the libraries, right? So PyTorch, NumPy. So you may need to install them. Okay. So you'll have to troubleshoot that. So I think I'm gonna pick Python 3.8 here. Okay. And you can see it just looks like a general, Jupyter notebook. So I'm gonna do this. If you're reading your file, let's say that you have you've already scraped your data, you've collected all your vet GPT data, then you would read, let's say this is a function, right? So something like pandas.read or something like that. And then you would provide literally, you would say something like scratch scholar, and in my case, our Calix, and then let's say, you have a folder in there, vet data. You see that? It's that easy. Okay. So the key thing is you will collect your data probably on your laptop, right? You'll scrape the internet over some time. Once you've collected all those files, however you have them, you're going to upload them to Scholar into this one over here, right? And then once you have that in there, you can view it through the terminal, for instance. And then when you're running your code from here, you would read it in like that. So it'll know how to find the scratch data. Got it? Does that make sense? All right. So yeah, so you'll play with your Jupyter. Some of them have certain libraries already installed. Others don't. I think this one should have Torch already. Right, so there it is. So the dot went clear, no errors. So I have Torch in here. So then just a couple of quick things that you might want to do to check things out. So today's topics are located on the GitHub. We go to deep learning algorithms, second edition. I'll add these later to Brightspace. And it's going to be chapter 2. All right. So today we're going back to chapter 2 a little bit. Feel free to read the material. The notes are there. And these are more like basic topics that we're going to cover today. Kind of, we covered a whole algorithm GPT. We've covered tensor operations. Hopefully you've done the 109 problems. Now I'm going to, in these set of problems, I'm going to look at the issue of how to train, right? So, the optimization a little bit, what PyTorch does for you, which is calculating the gradients. We're going to look at several individual simple examples. But as for convenience, I also added here check GPU info, just so that I recommend that you add this in whenever you're running on Scholar. So you can see I'm going to add from Torch, torch.cuda is available. Okay, and it says true. You want to see that. If you run this on your Mac, it's going to say, on a laptop, I should say, it's going to say false. If you do this wrong, like if you select from the queuing system a machine, but actually you were given a CPU, it'll say false. All right, so this confirms to you that you do in fact have a GPU. Right, so I recommend you do this first. And of course, obviously, you'll see that the training is going to be very different. When you're coding, I would recommend, do your coding first on your laptop, right? Make sure that you figure out all the bugs, then load it to your GitHub or something. And then once you're ready for the big data set, then get a GPU from the school and start your training, okay? All right, so a couple of more things that I would check, generally speaking, is I like to check certain things. All right, so if CUDA is available, I want to see these statistics. So in this case, it says I have one GPU. The GPU ID is 0. If you had a second GPU, it would be ID 1, and then you have 2 GPUs. The GPU name says here it's a Tesla V100 PCIe, 32 gigabytes, and the amount of memory that you have available. Okay, so this tells you, okay, I can do my homework assignment to train my VED GPT, just barely. And it would take, well, this is a V100, so I think not 655 years, more of like 300 years. All right, so you can look up those statistics. Are really interesting. If you go to the Lambda labs, they actually provide very interesting stats. All right, that's it as far as Scholar. Are there any questions? Everyone get it? So this is what you would do. If you get on Scholar and get all this information and everything works, then you're ready to run the GPT code, basically.
How can we see the file structure, like where we are storing the data or something? Like, can we see it on Jupyter, or do we have to go?
You can see it on files. There's a
separately though, not in the same interface. Like not in the same interface as Jupyter.
What do you want to see?
Like in the Jupyter notebook, the application itself, can we see the file explorer and the folder structure, or do we have to open it separately?
I don't, and well, that's a Jupyter notebook. Wait, hold on. So this is a Jupyter notebook. I don't know that it has any menu to go where you want to go. You might be able to print from like with a command. If I understand correctly, what you could go here, and because this see, it tells you, and this here, you're in this folder, so that's that file structure. But there's the other ones, the Scratch one that I mentioned, so you can also look at that one. And my quota actually is a good way of remembering what you have available, what your account is linked to, basically. Yeah. Yep. So navigate through that. I mean, there's more. This is big. Unfortunately, it's kind of at the end of its life. I believe they're using like the operating systems from 2017 or something. So it's probably going to get updated soon. All right. But yeah. So that's Scholar. I'm not hearing any questions, so I assume you guys will play with this. Again, your kind of homework by tomorrow, make sure that you log in and that you're able to run a Jupyter notebook such as this one. That when you import Torch, no errors, maybe even run a few Torch examples in here, and then print out these statistics and so on. Got it? Does that make sense, guys? And you will use this for your homework, your VET GPT. Great. So I'm not hearing any questions. So then let's move on to today's set of topics. All right. So, and as I said, today I'm just going to motivate like with a problem. And we're just going to look at the process of how to train a model, right? So how can we train a model? Very simple example. All right. Since I don't really need a GPU. I'm just going to end the session. Okay, so to end the session, let's say that you did your, see, I still have an hour and 50 minutes, but someone may need this in the university for their homework or their research, whatever. So you can just click on delete. And that's it. So at that point, you've released the GPU. The files that you created should stay. As you saw, I had a whole bunch of files there in my file system so that they'll persist. They will only persist, I think, until the end of the semester. After that, the policy of the university is they'll erase your file. Maybe, I don't know. Okay, so download them. If you have something important, put it on your GitHub, etc. All right, so great. So I think we covered Scholar nicely, so I'm happy about that. Okay. Close that. All right. So now I'm going to kind of start the lecture for today. Since I knew I was going to do this and it's going to take some time, I just have some miscellaneous problems today that we can explore. So all of them, the common theme is that we're trying to learn, right? So as I said, when I did the first set of problems, the goal was kind of random data, but let's do operations on these tensors, right? And you saw all of those operations were really important to understand how attention works and how to calculate those things in when you're using advanced algorithms. But for the most part, the data was random. Here, though, it's going to be different. We're going to look at metrics and we're going to look at the process of training things. Okay, so just so I did provide a sign-in sheet, right? So if you haven't signed in, please do so. Okay, pass it around. All right, great. So let's go ahead. I'm going to use a Jupyter notebook here. So I'm going to start. Okay. Yeah, so I'm going to go ahead and start. I do have my, yeah. All right, so I'm going to start the Anaconda environment. And you guys can follow along. So really what I want to show today is this idea of how the weights are learned, this idea that calculus is used, and kind of we're going to do some operations there just to kind of convince ourselves, right, that this is happening basically in what PyTorch is doing for us. So let me do dir, desktop. ITS 520. Okay, let's. All right, so I'm gonna create a new folder for this one. I'm gonna call it learning ideas, I guess. All right, so now Conda environment list. None of what we're going to do today requires GPUs or anything. Is this actually going back to the very basics, right, of what's going on in machine learning? And I think we're using Py38 ML 2024. Py38 ML 2024. Okay. So I'm going to do Jupyter notebook. Okay. Okay, perfect. So we have something here. So I'm going to create the first notebook. All right. There we are. All this, of course, as usual, all the Jupyters are already on the GitHub, so you can get them from there. I will provide the link at the end of class today, but you can find it. So I'm going to go ahead to, the GitHub. And actually, it's going to be this one, Deep Learning Algorithms. And then second edition. And I added everything to this one, chapter 2, traditional ML. So feel free to read the material there. There's discussion that you can read as usual. And then these are basically the scripts that we're going to cover today. So we already did the check GPU info. So the other ones are Scratch optimization learning, Scratch gradients, gradient losses for Torch, normalized losses, curve similarities, and so on. All right. So that's kind of the idea. So I'm going to start motivating this problem by the idea of curve similarities. And what I mean by that is I'm going to have a curve, right? A curve. And I want another curve to be exactly like that curve. Do you see that? So it's the classic problem of sort of regression, right? Where you have some points and you want a line to be fitted to it. But instead of using that traditional example, I'm going to use more this idea of I have two curves. How could I get these two curves to be, I'm trying, I know what a curve looks like. I'm trying to build a model that should look like that. So an example I can give you is the stock market. Let's think of the stock market, right? We're following, or Bitcoin, right? It's something like that. So what do we know over time? Next year, we want to be able to predict so we can maybe short some of the investments or something like that. We want to know when it's going to go down, when it's going to go up. So we have this curve, and we would like to, given some parameters, be able to predict what that curve is going to look like next year, right? So the intuition here is I'm going to have one, and then a model produces another one, and my goal is for both curves to be on top of each other. So it's like in the end, I would only have one curve. Do you guys agree that that would give us the best results, right? And that, so there's metrics for that. That's a classic MSE, mean squared error loss, but I also have other interesting similarity metrics that we're going to use. Okay. All right. So that's the first example. So I'm going to do curve similarities. Then from there, we're going to kind of motivate with that the idea of normalization and softmax, just so that drive that home a little bit more. And we can discuss if it's a good approach or not. And then, of course, we're going to do gradients and gradients and differentiation. So that's really the thing that Torch does for us, right? That why we need it. And then finally, a temp optimization problem of fitting something simple like converting Celsius to Fahrenheit or something like that. Right. So I don't know if we'll have enough time to cover all these topics today, but maybe we will. All right, so let's go ahead. And so so you can see the Jupyters are here: curve similarities, normalized losses, Scratch gradients, and Scratch optimization. So I'm just going to start with this one, curve similarities, and we're going to start going through it in our code, and you can follow along. Any questions, guys? All right, so I'm going to go ahead, and I have a Jupyter here. So I'm going to rename it in class, and I'm going to call it learning examples. Just hold it there, and if someone comes in, they can sign.
Just wondering, did
everyone sign in, guys? Okay, sir. Yeah. All right, so let's go ahead. So in class learning examples, right? So let's start with curve similarities. We'll need to install a library for this one, as I want to not dwell on these algorithms. I'll kind of explain like one or two. I kind of like the ideas of them. Okay, so I'm going to go ahead and run it. All right, and as you can see, it gives me a a library is missing here, which is similarity measures. Okay, so I'm going to go ahead and try to install it. So pip install similarity. Just going to cut measures. Okay, but finish. So I'm going to comment this out. All right, there we are. Okay, so I'm going to draw the graph first, and I'm just going to kind of illustrate where I'm going with this idea. So this is, if you want to take a look at the original Stack Overflow and the original GitHub for similarity measures, you can check out those links. So the one important idea is these measures of similarity would return a zero distance between two curves that were on top of each other. So that kind of illustrates the idea of optimization, right? So we're minimizing losses to zero or a metric to zero to make one curve look exactly like the other one. But although this sounds trivial, it may not be, right? So it may be very challenging. So that's kind of what we're going to do. So this is just me creating the data sets. But yeah, so first thing I'm going to do is create the graph, right? So let's go ahead and do that. All right, so I'm going to have X data is going to be 100 random samples. So actually, let's print these individually. It'd be better to do that. So how do we look at this, right? We want to do X dot shape, generally speaking. And we have 100 samples there that have been initialized randomly, okay? Gonna do the same here with X. So for so notice this one, for I in range 100, and I'm just using a list comprehension to create a list of indices from 0 to 100 and then converting it to a NumPy array. So I can do X dot shape. See that there. We can take a look at this one. X. And you can see it's got 100 random values. If we run this one, and then X again. And this one is just the indices from 0 to 100, okay? So this is so I can create my graphs on the X-axis. I'm going to have from 0 to 100. And then on the Y-axis, I'm going to have maybe random values or something like that. So I'm just creating two plots. And then, like I said, we would think about training them. So the goal of this is to compare them, basically. How do we compare them, right? All right, so I've done this part here. We can do the same for Y. Create another set and print it. And you can see, so we have X and Y here. All right, now we're going to create a matrix. And the reason why I'm creating a matrix like this is just these metrics in particular want the data formatted in this specific way. All right, so I have generate random experimental data. So notice I'm creating a NumPy array of zeros with 100 rows and 2 columns, and it's called experimental data, and it just takes in X and Y here, okay? So Y is random values, X is the indices. Does that make sense? So let's take a look. Done. I'm going to do some slicing, exp underscore data. And what do we want? Let's say from the beginning to 5, and then both columns, right? So you can see there, I have 0, 1, 2, 3, 4, and then those values, which are random. Got it? Got it, guys? All right. So I've done that one. Okay. And now I'm going to so these values like that. Let me try this. Do you see that I was able to just offset them all? They still remain the same like distribution, if you will, but I offset them a little bit by adding 4 to them. Okay, got it? All right, so I created one data set. And this is just a graph. That's all it is, right? So imagine a graph on the x-axis is just 0, 1, 2, 3, 4, 5. On the y-axis is these values, so I can plot it in some shape, okay? All right, so I'm going to take a look at the next one. So I'm going to generate another one. This is called num data, and this is, it doesn't really matter. One is basically the, let's say the real data. This would be the stock market data. And the other one would be what my model generates, right? At the end of the day, what I want to do is I want to find a set of weights from my model that produces a line that's on top of the other line. Do you guys see that? That's kind of what's happening here in this example. So generate random numerical data, pretty much doing the same thing. Y is numerical data. And then I just use the same X because it's the same. They're both going to be on the same axis, x-axis. So I'm going to proceed to do this one as well. And you can see I have 102 as well, right? And I can repeat the same exercise, but for num data. Okay. And I'm going to do 5, comma, all. All right. So now you can see these still in the 0.4, 0.1 area, and these are still in the 4 area. Make sense? All right. So I've got my two things, right? I have the thing, let's say one thing is the data. Imagine that this index 0, 1, 2, 3, maybe it's time, right? So today, tomorrow, whatever, and then that's the stock price. And then this one is what the model is predicting. So obviously they're not in the same place, but that's kind of the idea. So now let's just think of metrics, right? So we're just going to measure, some similarity matrices. Now, before I do that, though, I do want to plot the data. Okay, so I'm going to plot it just to kind of illustrate. Okay, so plot the data. So I'm just using, if you guys want to become really good at visualization, there's a course that we offer. Professor Gurjin teaches it. It's called Visualization. Talk to him. I think he covers things like this. All right, so plot figure. So we're plotting EXP data and num data. This is the index, and then this is the data index. So I'm gonna run it. And there you go. Nice, right? So as you can see, my goal would be what? For let's say that blue is the real, orange is the predicted. I want only to see orange, a little bit of blue there, which would mean we had some errors. But in essence, I want the data to be one on top of the other. All right, so this is part of these are just concepts of training. So what are the metrics that you can use for these? So one of them is the classic mean squared error, but we can think about this. There are other ideas that could be used here. Now, in deep learning, you usually only use MSE for regression, and then you're going to use cross entropy for classification problems. So everyone that tries to do something like this will try to fit with MSE. But I wanted to illustrate that there are other ideas. So for instance, think of the problem that I generate, I have a model, right? And the model is training. So this is the real data, and this is my orange predicted. So during training, it's going to do, let's say, 100,000 iterations. Every 5,000 iterations or so, it collects like the last 20 that it's generated. And it just gives me the picture. It just says, hey, here's the picture of what I did one time. And here's the picture of what I did another time. And here's a picture of what I did yet another time, right? So let's say that we're also having a really hard time training this model. MSE just is not working for whatever reason, right? We also don't really know how to improve it. So one solution that exists out there, which is called reinforcement learning through human feedbacks, is the fact that you basically admit that you don't know what loss function to use, how to train the model, and instead, what do you use? You use human feedback. So every 5,000 iterations, I get, let's say, 3 pictures. Let's keep it simple. 3 of these pictures. And one looks like this. One looks like that one. And one looks like somewhere in between. And then all I have to do is say, you know what? I don't know how to teach you to learn, but I can give you my feedback. I would say this is the worst. I would say this is a good one. So you just give it that feedback, and somehow the machine learning model can use that. That's a very advanced technique, but it's certainly like on the total extreme, right? So there's, of course, think of it as a range of what you can use to train the model. MSE cross entropy is like default, something like that, where you don't know what to tell, how to get it learned. And by the way, that's the loss function, or sometimes referred to as the objective function. You don't really know how to train it, honestly. How do you teach a robot to dance salsa, right? So what's the objective function for that? What does it look like? What do you normalize? And what's the regularization parameter, right? You don't know, right? So, but we start usually with MSE and cross entropy. On the total extreme, we have human feedback like that. I would say this is pretty bad, and then hopefully the model will learn. Obviously, I'll show MSE here, but actually, there's stuff in between. So you don't actually have to be MSE cross entropy, or you don't have to be like, I just know that this picture looks better. There may be other things that can be done to look at these curves and say, okay, I'm going to give you some feedback to learn how to improve performance. So ultimately, what do we want? You could argue we want this orange curve to be on top of the blue curve, right? They're not the same one, by the way. If you look, they're not the same curve. They may look, but they're not. So what's one thing that we can do? We can calculate some kind of a similarity score. And you can be creative here and create your own and all that. I just have like 6 that are available in this. I'm not going to go over all of them, but I'll just kind of give you an intuition of this one. So the one that I really like is something that you probably studied. I don't know if you guys can think of an idea of a metric. So we don't really need a human to look at it. There are things that we can do, like mathematically, algorithmically, that would give us a score of these 2 curves. What's one? What if we calculated the area between the curves? So you know what I mean? So if you start here, right, and then here, right, then what can you do? The area of the curve is something you can calculate with the integral, right? So you have the function, take the area under the curve, and it's this area. Then for the blue one, you take the area under the curve that includes the orange part, take the difference, and then you have an area. You see that? And that, let's say, I'm just going to quantify it as 10,000 or something. Well, obviously, if I move this orange line up here, what happens to that area? It's less, correct? It's less. So there you go. So that's a metric that you can use. I mean, I didn't invent that. It's in this library here, and I just read about it. But there are other very interesting functions in there to play with. Does that make sense? So I've given you like the intuition. what is an objective function, right? That's really what I'm trying to show you here. MSE, minimize squared error. But minimizing squared error may not actually consider the whole function, for instance, just a type of a metric. So there's actually some metrics from geometry that I think some of these are coming from that field that are also very powerful. At the end of the day, you give it this data and compare it with some technique, and it should give you a score. And then the goal is, if as we looked at the definition of these scores, the measures of similarity would return a zero distance between two curves that were on top of each other. So that means, for instance, as one curve is on top of the other one, it means that our model has become better, right? You know, it's better at predicting. You could argue that if your model is predicting that you should sell your house at these orange values when it's actually at these blue values, you're losing money, right? So, but as it starts, you know, obviously if it goes above, then you're over asking, no one's going to buy it. And so that's kind of the intuition here. Got it, guys? All right, so hopefully that made sense. That's kind of an example of what an objective is. And we just need a metric, right? And so now let's just look at these metrics. So I plotted the graph here. The first one is called PCM. Okay, so I'm just going to illustrate. I'm like I said, I'm not going to go over like the equations or anything, but one of them is MSE for sure. All right, so this one, quantify the difference between the two curves using PCM. It's something about mapping. I had the name. I can. Okay. Yeah, so you can Google it, like PCM symmetric, or actually, if we go to the link, let me just give you, because I forgot what PCM stands for. So this is the GitHub where they made the library, and you can see the same idea there. So here they are, I think. So partial curve mapping. So if you're interested, you know, if you were interested in like understanding how these things work, look for it. There's the discrete Frechet distance, dynamic time warping function, curve length, area method, and then of course mean absolute error, those famous L1, and mean squared error, famous L2. But these are very common metrics for regression problems. We've used them, in fact, already in the semester, but I'm just giving you like other ideas, right? Not all of these are available in PyTorch, unfortunately. Like, it would be really nice if this was a PyTorch function. As the last time I checked, this was not a PyTorch loss, but you know, that can change for sure. Okay. All right. So anyway, that you can read further if you'd like, but you know, my goal here is really just to illustrate. So let's go back to yeah. All right. So basically, I'm just using the library. I give it the EXP data and the num data. So basically, these two graphs. So how could you do this during training? As you guys have seen the process of training, you train the model, you give it the input data, it predicts output, right? So that might be this curve here, the orange one. And then you have the real, right? And so at that point, you take the two, you run it through your PCM score, and it gives you some kind of a metric. So you can see that it gave me a value of 192. Just so yeah, so right now we're just focusing in on these. There are technical issues, like I believe these are NumPy tensors. PyTorch does not like that, so you'd have to like deal with the mechanics, right, of converting from one to the other. But anyway, that's PCM, right? So you have one metric, 192. All right, let's take a look at another one. So just Yeah, so that was the data. Next one that I have in here, let's copy this. So this is the discrete Fredshit distance. You can read up. I'm pretty sure it's pretty complicated. Those of you like mechanical engineering and stuff, go crazy. All right. These are specific algorithms, I'm sure in topography or something like that. This metric gives me a value of 4.71. That's the similarity, right? So one issue is one gives me 192, the other one gives me 471 as a metric of difference. Now, when you're using the same metric, everything is going to be relative to each other, so that makes sense. What's the goal? To minimize this value, right? That's kind of the intuition, right? That we would want. So we might run an example to see if these actually are true, right? I'll remove that 4 that I had in there, and so the curve should be closer. Let's see what it does. Does that make sense? Just to kind of see our all right, but let's look at the other metrics. And then we'll take our 10-minute break after that. All right, so there's this one. We'll copy. This is going to be called quantify the difference between the two curves using an area between two curves. So this is area between two curves. Okay. 394 in this case. Take a look at another one. CL. This actually, no, this worked. Okay. This is curve length based similarity measure. So I guess the length of the curve, because if it's like doing this, right, it's going to be longer than a curve that's like this, I suppose. So there's that. Now, here's another idea. One looks at the length of the curve. One looks at area between two curves. So you could argue that they are looking at different things. Do you see what I'm saying? So hopefully right now you're thinking, okay, should I use two of these together? Do you see that? And what are the challenges there? It's not guaranteed, but if you know, whenever you're doing loss functions or things like that, you will have MSE, but you can add something called a regularization parameter, and you can add other things. I mean, even people do this all the time where they add losses. That's a thing, right? So this is kind of what I'm discussing today. I'm not giving you like a recipe, as there is none. You just got to experiment with this and read a lot. Okay, so that's another metric. Notice they have different scales, right? So 394 to 641. Okay, so then I'm going to do DTW. All right, DTW is quantify the difference between the two curves using dynamic time warping distance. You can read the paper for that one. I didn't read it. So 398, but it is in a different scale. And I believe the last ones are just MSE. Yeah, mean absolute error. So mean absolute error is supposed to be, my understanding, and there's one called the L. Huber something, MSE, but MSE is supposed to be less susceptible to outliers. So sometimes when you have a lot of outliers and you want to ignore them, maybe you use L1, although sometimes it makes no difference. All right, so there's one, see 1.99, look at the scale of this one, pretty small. And then finally, mean absolute squared error, or mean squared error, sorry, which is your famous MSE that we have talked about, mean squared error, similarity measures, and you can see this one, and there's the value. Okay, these are the default values that I'm getting. We can print all the metrics together. All right, and there you have them, right? So you can see them. Some are in the range of 192, some are in 471, some are 394. One is almost 2, 1.99, and so on. Okay, so we did that. Now I'm going to change the number, and we're going to remember some of these. So I have them printed here, right? 14.9, 21. All right, so now I'm going to go up here. Oh, wait, sorry, I'm in my, yeah, go up here. And I'm going to remove this 4. Okay, so now I'm going to do this. So obviously the numbers seem closer now, right? Do you guys see that? All right, so I'm going to do this, do that, going to do that. And I'm going to plot them. And you can see that, well, obviously it looks like what I had in the Jupyter notebook. They do seem to be closer, right? So that's what we want to check now. So this was 192.12. So it went down. So that's the idea with a metric, right? So in essence, you're minimizing it relative to other. It goes down to 0.8. 394 goes down to 20. 496. 398 goes down to 30. 199 goes down to 0.15. This one, 8.05, goes down to 0.06, and that's it. You see that? So obviously, how do we do that? We need to update the weights, right? So that's, you have a neural network that's predicting one of the lines with a set of weights. So we need to think about that, right? So how do we modify those weights? And that's going to be the learning process. But it's all based on a metric. And at the end of the day, because that we were able, let's say at the end of at the beginning of training, it looked like the two curves. At the end of training, it looks like that. And the metrics reflect the fact that they were going down. Does that make sense, guys? Are there any questions on that idea? All right, so that's the first of these scripts that I wanted to cover today. All right, so we finished that one. Curve similarities. In the next one, we're going to look at normalized losses, this idea. So continue with the thought of these curves and just, some insight there. All right, it is 6:24. So let's take a 10-minute break. So I'll end this video here, and I will come back at 6:34 to continue our discussion of some of this background. All right, so let's take a 10-minute break.